Continue from the previous video. Yes, we know this Minnesota coronary experiment because the outcome didn't meet what their expectation. So that's why they never published the data. However, this data is important. So since Dr. Robert Franz, the son, know about this message, he returned to his childhood home multiple times to search the basement for the record. So one day he did find that. He has discovered the whole chest full of the IBM computer tapes. That's including the record over 9,000 study patients, the age from 20 to 97. That's our close population we talked about earlier. Because all they living in the state mental hospital or a nursing home for 5 years. So that's the largest experiment of this kind. And remember earlier, we like you to think about if you try to design this experiment in current time, we really can have a lot of factors we cannot control. But this study, they are in a closed population. This almost 9,500 patients, they fully control their food, no matter they are treatment group or control group. So after Dr. Robert Franz find the data, so they passed to resident. So he reanalyzed the data and made the conclusion. So here you can see the resident, he re-evaluate the traditional Dutch heart hypothesis. So then they use this data. Then he has the conclusion. Replacement of saturate fat in the diet. They effectively lower the serum cholesterol, but doesn't support the hypothesis that this translates to a lower risk of death from coronary heart disease or all cost. So that's why the finding from the Minnesota coronary experiment add to growing evidence that incomplete publication has contributed to overestimation of the benefit replacing the saturated fat with oil, vegetable oil. So, do you want to see the data? So that's 9,423 patients' data. Here it is. And here you can see the line graph. I also make the color because here it's just a black and white. But we can see the treatment group. We say the vegetable oil diet. On this one, the line is thinner. Okay, so that's this one. Okay, so then the other one for the control group, we eat regularly with the saturated fat. And here the exit is the time in days. Remember we say they are 5 years, so almost 1,800 days. And the y-axis is cumulated population of the death. So that's the death rate. So you can see from the beginning, the first 500 days, they are almost the same. Even you see part of that is the treatment group have higher rate, but they almost overlap before the, I think in the first 400 days. For the first year, they are fine. So when the time goes by, the treatment group always higher than the control group. And during the time, they did see the cholesterol is lower, but it didn't support the death rate is lower either. So that's make us think about. They cook with the vegetable oil and serve margarine. Will margarine have some effect for our body or not. Pause the video and observe the graph. See what did you observe from this graph. So then we will see the data. So let's go to see our demo file. So we see the data, how they look like. Like earlier we say, we see this data, we have more than 9,000 data. However, they already group in according to the age. So that's why here, when you run the data, you will see the table. Okay, so they don't have the 9,000, more than 9,000 row. Instead, they only have 1, 2, 3, 4, 5. Each group, they have 5. Each treatment group and the control group, they have 5 different categories. They have the age, because earlier we say the age is from 20 to 97. So that's why they have 5 different categories. So you have, here we have the age. So then you can see the condition on the dial to mean the treatment group. Then we have the control group. Then each category, we have their, the number of the subject, how many patients. Okay, so then also they have the death. Okay, so then the CHD deaths. So the CHD deaths, we can see that's the heart disease death. So that's what we can see here from the death number. We do see from the treatment group, actually they have more death number than the control group. But according to the heart disease deaths, the control group did have more number. But those thing is, if we want to do more analysis or do our A/B testing, we cannot have for each group. So instead, we really need to convert this table. Instead of we have the 12 row, we need to change for each row have 1 patient. So like earlier we say we have over 9,000 patients. So that's here, we convert our original table into each row have 1 patient. So then here you can see in the same group the age, then according to the condition. Okay, so of course they are participated. Okay, so then from here the age group, so like 0 to 34 in the dial group. So earlier we can see here we have like 1,367. So we need to make this one, each row has 1 patient. Okay, so then of course since they have 3 death in this group, so we just make that the died column we see true or false. So from here, then we have our 94 on 23 row. And so you can see the source code here. So basically, we just convert the original table. We change to code the subjects table. So then we convert from each group the number of the patient. Instead of they only have 1 category, we just make each row has 1 patient. Of course, if you group again for the condition and the age, so that's back to our original table. So then, of course, we need to assign each patient, they are either die or not. So from here, actually, we can start doing our A/B testing. Okay, so of course, we can just rearrange to label that. Okay, so let's go back to our lecture file. So here I only show you the line graph, but I forgot to show you also we have this table. Like we said earlier, we have the master thesis. So then they have the data they use. So that's the Brost thesis. So you can see this table. That's also the same table we have earlier. So we have 5 different age group. Okay, so then you have a control group and dial group. So each age group, they have the individual number and the number of death. And also the most important thing, we have the percentage here. So when we have see the same age group among the dialed group and the treatment group and the control group, we can see from the younger age, they are fine because they are 0.2 and 0.5. even 0.2 and 0.5 look big, but since the number is so small. So then here you see between 35 to 44, their death rate about 0.4 and 0.5, they are almost, they are very similar. And 45 to 54, they are 1.8 and 2%. So then even the 55 to 64, they are 4%, 3.7%. But one thing is for the age over 65, you can see here for the treatment group, the death rate almost 20%, but the control group only 17%. So that's why here is what we wonder. This age group, actually their death rate have higher difference. So does that mean in this group, actually the polyunsaturated fat kind of harm a little bit or increase the death rate? That's we are interested to see. So then we can go back to see our data. So after we convert each group into the individual role for each patient, so then the same thing, but we still have our age group. But that's good enough. We can from this almost 9,500 rows. So we can compare their death rate between our treatment group and control group, and also in different age group. Okay, so that's why our test statistic is, we will just see the rate different. Okay, so then you can specify which table. So here you can have the rate different by passing the table. But on the other hand, if we passing the table, if we only have specific age range, we also can see the rate difference between different age range. So for example, that's why you can see for overall, the rate difference, if we see the whole subject table, that means we don't have the age group. We just see the treatment group in whole and the control group in whole. The difference for their death rates is, it's less than 0.5%. Also, it's not much. But here, if we see the rate different according to the age group, okay, so for the youngest age group, the rate difference is 0.003. So that's actually is below the overall. But if we see the age group is 65 plus, then you will see here the rate difference is really high, right? Like earlier we said they are about 3% different. But overall, they are only 0.5% different. So this one kind of really have big difference. But even though we using the rate difference to compare with the overall rate difference or in different age group, but kind of still not, it's kind of very subjective for the rate difference. So that's why we do continue to do our A/B testing. Okay, so then of course we repeat many times. But since here the data is quite big, so we just repeat 200 times. Okay, so then, right, we can see the rates different. But also, since we will repeat many times, right, instead of we only have the rate different, so maybe we should also find the p-value. Okay, so that's why we will also know, should we reject or accept the hypothesis. Okay, so that's why here we will find the empirical p-value. Okay, instead of only see the rate different. Okay, so then let's see here. Okay, so the same thing. Yeah, this one actually already wrong, but you have the sample file. Please make sure you also wrong, because different simulation, the result will be different. Okay, so then here, after we have this A/B testing function, okay, so then we will see here we have the each group rate different, and we have their p-value. So that's why you see from the lower age, under 34, their p-value is 0.165. Okay, so then the rest of that, they are more than 0.8 or 0.7. So those things definitely we won't reject the null hypothesis. But then you can see the last age group. For the age group, so those younger age group, their death rate doesn't have much difference. Okay, but you can see here for the age over 65, their p-value actually is like 0.065. Right, actually very close to the 0.5, right? So then it's actually compared to the rest of that, this one is very close. We will reject the null hypothesis. Okay, so time's up. So then, yeah, this one is our lecture 38. So our example for our health case study.